stuff now. So back to the board. So once you have this description on the accelerate or velocity, you can then just differentiate this and you have a nice equation for your acceleration. So we have the acceleration of p prime is going to be the acceleration of the center plus the acceleration of p relative to O plus the acceleration of p prime relative to p. Now, why don't we look at the directions that these different components have to take? What direction is the acceleration of p prime going to be? Acceleration of p prime. Along this line, isn't it? Is that all of it?
It might have a tangential.
It might have a tangential. Okay? It's got a normal pointing back towards its rotation center, but it's also got the probability of a non-zero tangential acceleration. Highly likely. So the way I would write that acceleration of p prime then is I would write it as a full-blown, fairly complicated mess. And it's going to be omega of Cp prime crossed with omega Cp prime crossed with r of c relative to p prime. Right? Is that correct?
It didn't have one tangential component.
Hmm?
It didn't have a tangential component. Would it come out to be zero in your math?
Yeah, it should shake out if it turns out to be zero. And so then plus the alpha of Cp prime crossed with r of c relative to p prime.
And that's it. And that second part's a tangential chunk that may or may not go away.
You know, actually, I have this backwards, don't I? Acceleration of p prime is reference to what point? It's reference to its point of rotation. So to be safe, it should be that way, and I was able to catch that by thinking about that for a second. And I would also catch that if I did my math and I saw that this thing was not pointing back up that way towards C from p prime, right? That normal, that r omega Cp prime squared better be pointing back up towards C. You with me on that? Look at the picture over here. Okay, so I would have caught the mistake if I'd carried forward there. So I have to reverse these r position vectors. So this is p prime relative to C and p prime relative to C vectors. So that's that left side. What about acceleration of O, center of the wheel?
V naught is constant, right?
Yeah,
So
our piston is constant velocity, so that means the center of the wheel's got no acceleration. And it's moving in a straight line as well. Constant velocity, straight line, no acceleration. So we get to zero that term out. Okay. Now, what about this term P relative to O? P relative to O. The P is the pin on the circular wheel, relative to its center. How's the wheel rolling? At a constant rotational rate too, isn't it? Doesn't it have a constant omega as it's rolling along the ground there? Yeah, so all this is going to have is an omega cross R, or simply an r omega squared, right? Directed back towards the center of rotation O. So I would probably just write this as r of OP times the omega of OP squared. There's my magnitude. And I'd make sure my direction was defined, pointing from from P back towards O. So from P back towards O is going to have a minus sine theta term and a minus cosine theta term. Minus sine theta I minus cos theta j. And then finally, this last one, this now gets us, oh, and there's no alpha on this guy, on the rotating wheel, right? No alpha. There could be potentially in this problem, if we had more other information provided, there could be an alpha of OP k hat crossed with R of P relative to O, but this happens to be 0 because the wheel is rotating at a constant speed. Okay, and finally, this last term is the acceleration of P prime relative to P. Okay, if we go back to our beta angle geometry, we can use it, and we had a length. What was this length to our P prime from C? What was that geometric length when we were at 30 degrees here? 1239
meters. Yes.
Okay, thanks. Okay, so the acceleration of P prime then is going to have a normal component this is a P prime relative to C normal, pointing back that way. And then perpendicular to that would be an alpha term, acceleration of P prime relative to C tangential.
Not that it'll matter in the long run, but wouldn't that be the other way? Because it's technically slowing down.
Well,
Not that it would matter in the long run.
well, I define this angle beta this way. So I'm just trying to be consistent with a positive sense of beta. Okay. As it being an unknown quantity. So there's two ways you can approach that. You can carry out the, similar to what we see back over here on that last term, you can have this, here's that normal type of term, the R omega squared type of term. Here's an R alpha type of term. We could set it up all that way, but it probably would be easier to take that unknown magnitude, which is an R omega squared of that number. Okay, and that's going to be the, I'm going to go ahead and put the numbers in here so you see it. 0.1239, there's your R. What was the omega of that CP prime member?
18.22 radians per second.
18.22 squared, and we're going to point it back up there that way from P prime towards C, so you have to go minus sine beta I and plus cosine beta j. While we're at it, our beta reading was about 23 degrees?
23.8.
23.8 degrees when theta was 30 degrees. Okay, so those numbers will get dropped in there. And are we done with that acceleration of P prime relative to P?
There shouldn't be any angular acceleration between them.
There
Shouldn't.
be.
Okay, well, that could be a conjecture that there is no angular, no alpha, but let's just put it in the in here and see if it zeroes itself out. Okay, because the math will tell us if we got it or not. Okay, if our conjecture is reasonable. So then we're going to add to it the unknown, and I think what might be easiest, folks, is just write this as an R alpha term, and then make sure you point it perpendicular to this normal that we just had. okay? It's quicker than doing alpha cross R. Okay, so let's do that. And again, we have that lever arm 0.1239 and the unknown alpha of member CP prime. That's our scalar magnitude. And then we need a direction now that is in that tangency. So that's going to have a reversal, a positive, positive, isn't it? And so if this is beta off a vertical, then that means this is beta off of a horizontal. Beta off the vertical becomes beta off the horizontal for the orthogonal acceleration vector. Okay. So you can look at that really easily and see that you're going to tag a coefficient, or excuse me, a unit vector on there with a cosine beta I plus a sine beta j. Any questions? Okay. So if you folks have your calculators handy, let's write down some omegas while we're at it. We wrote down omega of CP prime already. That was the 18.22, right? And you know, while we're at it, let's go ahead and tidy this guy up, because this is a pretty easy one, isn't it? This one points which way? P prime back towards C, right?
Yep, in the same way as the, not sure what to call that.
P prime relative to C. What did I write over there?
It looks a lot like what you have on that right side there.
We have one pointing in that direction anyway. Second sum.
What's going on here? It does look like that stuff, doesn't it?
With what you drew up there, that looks exactly what it is.
Yeah.
We just combine the scalar into that.
Acceleration of P prime. Let's see. Acceleration of P prime relative to C. And this is the velocity of P prime relative to C, because P prime's fixed on that link. So that looks okay. This looks okay. Oh, I know what the problem is. All that stuff over there is this. Everybody agree? Okay. So what I'm going to do is I want to move that stuff over here just to make sure I've got it written down. Okay? And then I'll clear up what this issue is right here. And you might already know what that is or not. I'm not sure. So anyway, what we're going to get there is we're going to have that 0.1239 times the 18.22 squared. And then we have that vector tied onto it, minus sine beta I plus cos beta j. And then we add to it, it's our alpha term, which is the 0.1239 alpha CP prime times the unit vector cos beta I plus sine beta j. Okay, that's equal to this stuff. I'm going to go ahead and rewrite. Let's see, we know some of this. OP was 0.1, right? So we have a 0.1, and then the omega of OP was, what was our omega OP?
It was 15 radians per second.
15 radians per second. Squared. And then we had a minus sine theta I minus cosine theta j. And actually, I can go ahead and put 30 degrees. We can put our angles in there in a second. And now let me clear up what's wrong with this. This is an unknown magnitude, this acceleration of p prime relative to p.
That's what we're trying to find, isn't it?
Well, it's one of the pieces we're trying to find. This is an unknown magnitude, right? So it's a magnitude, acceleration of p prime relative to p. And what direction is it pointing?
It's got to be pointing along the line.
It's got to point along the line. Remember how we drew our two arcs? Come back over here for a second.
They're lined up.
As soon as the camera gets over here. Okay, you guys, there we go. Okay, thank you. So notice our two arcs. When we did these two arcs, here's our cycloidal path, here's the path of p prime circular. And the velocity, the relative velocity of p prime relative to p is that way, back towards c, only. Okay, there's no tangential thing or any of that on velocity. That's the direction of its speed. Its relative acceleration is exactly that direction as well. Okay? Because p prime are always going to be in motion along this slotted path from each other. So that's an unknown magnitude, and it points, the acceleration term also points back towards c. And I think we already had our unit vector looking pretty good here. So here's the unknown magnitude tied in there, and then we have a minus sine beta, which is to the left, and a positive cosine beta up. So that's what I should have put there. So I knew something was looking fishy. So then we have right here the acceleration of p prime relative to p times this minus sine beta I plus cos beta j. Okay, now you look down here at this equation. When you get this big mess together, where are your unknowns? What are your unknown quantities there?
Alpha, CP, and the
Here.
magnitude of P prime relative to P.
Yeah. So those two circled items are our only unknowns. And all we have to do is equate the I terms and the J terms and solve for those missing acceleration values. Okay. Let's go ahead and go forward with